Let's slow down and actually explain why this is such a problem, because the science here is genuinely fascinating once you understand the mechanics. Galaxies don't appear instantly. They build up mass over time, primarily through gravity slowly pulling gas and smaller structures together, and through galaxies merging with one another. The Standard Model makes fairly precise predictions about how much mass a galaxy could plausibly accumulate within a given amount of cosmic time. Some of the galaxy candidates Webb has photographed appear to hold roughly as much stellar mass as our own Milky Way, a galaxy that took over 13 billion years to build. Except these candidates appear to have done it in a few 100 million years. That's like finding a fully grown, fully educated adult in a hospital nursery meant for newborns. There's a second layer to the mystery that's arguably even stranger. Normal galaxy formation is a messy, inefficient process. Most of the raw gas available in a young galaxy doesn't turn into stars. It stays as gas, drifts away, or gets blown out by radiation and stellar winds. Typically, only a small fraction of available material actually converts into starlight. But Webb has identified a handful of ultra-early galaxies that appear almost entirely quenched, meaning they burn through their star-forming fuel at an efficiency far beyond what current simulations predict, then abruptly stopped forming new stars altogether, all within the universe's first billion years. Imagine a wildfire that burns through an entire forest in a single night, then simply goes out, with no explanation for how it started that fast or why it stopped that suddenly. Researchers have also flagged a mysterious population of compact, extremely luminous red objects nicknamed, quite literally in the scientific literature, little red dots. Their light signatures are strange enough that scientists still can't agree on what they actually are. Overgrown black holes devouring gas at extreme rates, unusually dense pockets of ancient stars, or something not yet categorized at all. Here's the question scientists still can't answer. How do you build something that mature, that fast, using only the raw materials the early universe is supposed to have had available? As Webb's survey data has piled up, through deep field programs studying thousands of galaxies at once, the pattern hasn't faded. It's sharpened. Among the most jaw-dropping individual discoveries is a galaxy catalogued as one of the most distant confirmed objects ever observed, its light having traveled for more than 13.4 billion years to reach us, meaning we're seeing it as it existed when the universe was roughly 2 to 3% of its current age. And rather than a shapeless blob of infant gas, spectroscopic data suggests a surprisingly settled, chemically enriched system, containing heavier elements that are supposed to take multiple generations of stars dying to produce. Multiple generations of stars. In under 300 million years. That's the paradox in a single sentence. Then there's the sheer number problem. It isn't just that a few outliers exist. Webb has identified dozens of candidate galaxies in this too early, too massive category, clustered across different survey fields, observed by different instruments, analyzed by competing research teams. When independent groups using different methods keep finding the same anomaly, it stops looking like an error and starts looking like a signal. Would you have believed any of this if it hadn't been captured, catalogued, and cross-checked by multiple observatories and teams? Some candidates have since been partially explained. Reanalysis has shown a portion of these objects may be dimmer, less massive, or more ordinary than first estimated, once black hole contamination or dust effects are factored in. Science is supposed to work that way. Check, recheck, correct. But even the most conservative reanalyses still leave behind a stubborn handful of galaxies that remain difficult to explain, objects that refuse to shrink down to normal, no matter how carefully the data is scrubbed. That residue of unexplained cases is exactly what's keeping cosmologists up at night. The third camp is the most radical, and the most talked about. A number of physicists have proposed that our standard cosmological model may be missing something fundamental about the earliest moments of the universe. Perhaps an unaccounted for burst of accelerated expansion, or an era where gravity itself behaved differently than it does today. Some have gone as far as questioning long-held assumptions about how dark energy behaved in the universe's youth, a subtle tweak that, if correct, would let galaxies mature far faster than the textbook timeline currently allows. Notably, this isn't happening in isolation. It's unfolding alongside a separate, already well-known crack in cosmology called the Hubble tension, a persistent, unresolved disagreement between two different methods of measuring how fast the universe is expanding, each producing a different answer that refuses to reconcile no matter how precisely it's measured. Some physicists now suspect these two mysteries, the two early galaxies and the Hubble tension, might be symptoms of the very same undiscovered flaw in our model. What if these aren't two separate puzzles at all, but two shadows cast by the same missing piece of physics? In the mountains of Chile, on a night that started like any other, a machine opened its eye for the first time, and in 10 hours, it found more moving objects in our own solar system than every telescope on Earth had found in the previous month combined. No one was ready for that number. Not the engineers who built it. Not the astronomers who had waited 20 years for this moment. Not the scientists sitting in front of their monitors at 3 in the morning, watching the data stream in and slowly realizing that what they were looking at didn't just break records, it broke expectations. Because this wasn't a telescope in orbit. It wasn't hovering a million miles from Earth in the silence of deep space, the way Webb does. It wasn't floating above the atmosphere the way Hubble has for over 3 decades. This machine was standing on the ground. Right here, on our planet, breathing the same thin mountain air as the people who built it. And somehow, it was seeing farther, wider, and faster than almost anything humanity has ever pointed at the sky. What if the next great leap in astronomy didn't come from leaving Earth at all, but from finally learning how to look up in a way no one had tried before? Stay with us. Because what this machine captured on its very first night is going to change the way you think about the sky above you, and by the end of this video, you're going to understand why some astronomers admitted, quietly, that the images frightened them a little. Let's start with a simple question. When you look up at the night sky, what do you actually see? A few thousand stars, if you're lucky enough to be far from city lights. Maybe a planet or two. The moon. If you're patient, a shooting star. That's it. That's the entire universe as far as human eyes are concerned. A handful of pinpricks scattered across black velvet, appearing utterly still, utterly permanent, utterly quiet. It's an illusion. A comforting one, but an illusion nonetheless. Because the sky is not still. It never has been. Stars are exploding right now, in this exact second, somewhere in the observable universe. Galaxies are colliding in slow motion, their spiral arms tangled together like smoke caught in a photograph. Asteroids the size of buildings are tumbling through space on trajectories we've never mapped. Objects from other star systems entirely, visitors born around suns that aren't our own, are passing through our solar system, and until recently, we had almost no way of knowing they were even there. The universe is loud. We've just never had an instrument sensitive enough, wide enough, and fast enough to hear it. That's what changed in June of 2025, when a new observatory in the Chilean Andes opened its aperture for the first time and produced an image so massive, so dense with information, that it took the scientific community days just to begin processing what they were looking at. This is the story of that telescope, what it saw, why it matters, and why some of the discoveries buried inside its very first images are still keeping astronomers up at night. To understand why this moment felt so seismic, you have to go back more than 2 decades, to an idea that seemed almost absurd at the time. In the early 2000s, a group of astronomers began asking a question that most of the field wasn't equipped to answer. What if, instead of building a telescope to stare intensely at one small patch of sky, you built one designed to photograph the entire visible sky, over and over again, every few nights, for 10 straight years? Not a portrait. A movie. At the time, the technology to do this barely existed. Cameras weren't fast enough. Data pipelines weren't powerful enough. The idea of capturing, processing, and analyzing that much information in near real time sounded more like science fiction than an engineering proposal. But the scientists pushing the idea, including the astronomer Vera Rubin, whose research decades earlier had provided some of the first solid evidence for the existence of dark matter, understood something important. Some of the universe's greatest secrets aren't hidden in faint, distant objects. They're hidden in change. In things that flicker, brighten, dim, move, or vanish. And you can't catch change by taking a single photograph. You have to keep watching. It took roughly 2 decades of design, construction, delays, and international collaboration to turn that vision into physical reality. High on a mountain called Cerro Pachin, in one of the driest and clearest stretches of desert on Earth, engineers built an observatory unlike anything that had come before it. They named it in honor of the woman whose work had hinted, so long ago, that the universe was hiding far more mass, and far more mystery, than anyone could see. By the time construction finished, the world had almost forgotten to expect anything unusual. And then the observatory turned on. But here's the question that had been quietly haunting the project for 20 years. Could a ground-based telescope, wrapped in Earth's turbulent